The last transformation that we're going to look at for these sinusoidal functions is the period. So the period, of course, is the length of time it takes before the cycle starts to repeat itself. And so we can change that. It isn't always going to be 360 degrees. We can alter it either by compressing it or by stretching it out. First thing I'd like you to do is go into Desmos, and you either use this link or it's in your Google Classroom too. And all it is the y equals sine x function is there, but I've changed the period. So you can use your slider to see what happens as we change that b value that's inside your function and what happens to your graph. So pause the video here and give it a try. Okay, so what you should have noticed is that when we have this number that's being multiplied directly to the x, it changes the period of the function. So it either stretches it or it compresses it out. Now, to figure out what the period is of the sinusoidal function, we take what a standard period is, which is 360 degrees, and then we divide it by whatever that b value is inside of your brackets. And that will tell you that length of time or the length of degrees it takes in order for one cycle to occur. And that's the period of the function. All right, so what does this do for our graphs, okay? So let's begin. For example, let's say we had y equals 3 cos 2x. Well, there's a couple of things that we can talk about with this. First off, we can say that 3, of course, is a change in our amplitude. Our amplitude is 3. But our period now, I guess I should be consistent here. So that 2 means that there's a change in the period. And to figure out what our new period is, we would go 360 divided by 2, which is 180 degrees. So now instead of it taking 360 degrees in order for us to do one cycle of our graph, it's only going to take 180 degrees, okay? So you can think of it as being compressed, okay? Kind of smushed in a little bit. All right, so how does that affect our table of values? That's where the interesting part comes. So I'm going to start, this is a cosine graph, so it starts high. So it starts at 1, and then it goes low to -1, and back up high. Okay, and again, whenever I'm applying transformations, I'm always going to apply them in the order in which they come. So I'm going to start with that 3, that change in that amplitude. So I'm going to multiply all my y values by 3. 1 times 3 is 3, 0 times 3 is 0, -1 times 3 is -3, 0 times 3 is 0, and 1 times 3 is 3. So that's there. And then the 2, which is what's next. So that's changing the period. So notice I said it's compressing it, okay, because it's kind of squishing it in. When we multiply by our b value, it's going to be 1 over b, okay? So it's always going to be 1 over whatever that number is. So I'm going to multiply by 1/2, okay? By multiplying it by 1/2, it compresses it. It makes it so that it doesn't take as long for a cycle to occur. Right, 1/2 times 0 is just a 0. 1/2 times 90 is 45. 1/2 times 80 is 90. 1/2 times 270 is 135. And 1/2 times 360 is 180. And so now these points are going to be the ones that we're going to plot. 0, 3, 45, 0, 90, -3. 135, 0, and 180, 3. Okay. I'm just going to copy these. And let's go over. I have a grid over here on the other page. Here's my grid. All right. And this was from A. So let's plot these points. So 0, 3, and then 45. So these, my grid goes up by 30. So 45 would be halfway in between 30 and 60. 120, 150, 210, 240, 300, 330. Okay, so 45 and 0 is going to be here. And then 90 and -3 is down here. And 135 and 0 is back up here. And 180 and 3. So that is definitely compressed in. We can see that. Now, let's kind of keep going with this. So I'm going up by 45. Let's put in another cycle here because we have lots of room. So let's keep going. So I noticed I went 0, 45, 90, 135, 180. So I'm going up by 45s. The next one's going to be 225 and then 270 and then 315 and then 360. So that's going out by 45s. And then this pattern just continues. So 3, 0, -3, 0, 3, 0, -3, 0, 3. So we can go on with our pattern and keep going. So 225 would be here and 0. 270 and -3 is down here. 315 and 0, and then 360 and 3. And so it's actually not hard for us to graph 2 cycles of this within this grid, because I went all the way up to 720. And of course, we could keep going with this too, but I think 2 cycles is probably enough. All right, let's take a look at the next one. So that was A. Let's try B. So y equals 2 sine 1/3 x. All right, so I got to think about this one for a minute. First off, we're using sine. So I'm going to start with my base graph for sine. So that starts at 0 and then goes up to 1, back to 0, -1, and then 0 again. I have a 2 that's being multiplied to my sine x, so that means I'm going to multiply all my y values by 2. So 0 times 2 is 0, 1 times 2 is 2, 0 times 2 is 0, -1 times 2 is -2, and 0 times 2 is 0. And then I have that 1/3, so 1/3 x. So remember, we multiply by 1 over b. So this is going to be 1 over 1 over 3, which is just 3. So we're going to multiply everything by 3. So 0 times 3, which is 0. 290 times 3, which is 270. 180 times 3, which is going to be 420. 440. Whoops. Let me just double check that. 540. Cheapers, way off. 540. 270 times 3. 810. 360 times 3, which is 1,080. So this is definitely really stretched out across that x-axis. 0, 0, 270 and 2, 540 and 0, 810 and -2, and 1,080, 0. All right. Well, let's go over to my grid here. And this is going to be B. I don't know where to put this. I guess we can put it down here. So B is going to be in red. All right, so it starts at 0, 0, so that hasn't changed, but now it's going to go 270, 270, and all the way up to 2, and then 540, and back to 0, and then 810, which is, these go by 30, so about here, let's say. So I'm not even going to get in a full cycle on this grid. Sorry, I kind of missed, so I'm going to try again. There we go, and then it's going to go up. So be down. So look at that. That one was really stretched out. We didn't even get a full cycle in on that grid that I have, but that's because it's completely stretched out. Okay, let's take a look at one more. Let's take a look at C. So again, this has a couple of transformations. Look at that there. All right, a couple of transformations. Let's do this one in green. And since it's cos, 0 and 1, 90 and 0, 180 and -1, 270 and 0, and 360 and 1. All right, 1.5, 1.5. So remember, it's 1 over 1.5, which is going to be, 1.5 is 3 over 2, which is going to equal out to 2/3. I'll show you that maybe on the side here. So 1.5 is the same thing as 3 over 2. So 1 over 3 over 2, which means we're going to multiply by the reciprocal. So 1 times 2/3, and 1 times anything is the same number, so 2/3. So we're going to end up multiplying this by 2/3. So you multiply by 2, divide by 3. Well, anything times 0 is still going to be 0. This 90, so we're going to go 90 times 2, which is 180, divided by 3, which is 60. And then 180 times 2 divided by 3, which is 120. And now you may notice from 0 to 60 is 60. 60, 60. So this next one will be going up by 60 also, because there's always a pattern to this, right? So 180 and another 60 degrees, which is 240. Okay, and then we have this +1 at the end. That means we're adding 1 to all of our y values. We're moving our sinusoidal axes, or our equation of the axes, up by 1. So 1 plus 1, which is 2, 0 plus 1, which is 1, -1 plus 1, which is 0, 0 plus 1, which is 1, and 1 plus 1, which is 2. So now what we have is 0, 2, 60, 1, 120, 0, 180, 1, and 240, 2. And these, these will be our points that we will put on our graph. Okay, so I'll just put that there. This is going to be C. All right, 0, 2 is here. 60, 1 is here. 120, 0 is here. 180, 1 is there. And 240, 2 is here. So look at this. Nice little graph right in there. And again, just like the one from A, we could keep going with this. Remember, it is all symmetric. So we're going up by 60s. I could definitely, increase my points by using my pattern, but I can see it right here. I can see that I'm over 2, up 2, right? So it's over 2 again. Now I'll go down, over 2 again, and then I'll go down, over 2 again, I'll go up, over 2, go up, over 2, go down, and we can see this lovely pattern that is emerging, this periodic function. There we go. We can fit a whole bunch in there. Okay. So a little bit of practice with this out of your textbook, and then there's some extra ones there to graph. I would definitely, I want to highlight this one down here as it's a little bit harder, a little bit trickier. See if you can figure it out. Of course, you can always check your graphs on Desmos too, so feel free to do that also. If you have any questions, reach out.